Hello, everyone. Good morning, good afternoon, and good evening, and welcome everyone for joining from over the world. Welcome to today's session of the ITU Digital Transformation Dialogues. My name is Thomas Bascoro, Program Officer at the International Telecommunications Union ITU, and I'm happy to be the MC, Master of Ceremony, for today's session. Before we begin, I would like to take a moment to discuss the session format. Today's session is part of a larger series of the ITU called the Digital Transformation Dialogues. In its new form, the Digital Transformation Dialogues bring experts from a range of industries and specialties together for webinars, Ask the Expert session, such as this one, as well as fireside chat sessions. Today's session will explore the convergence of semiconductors, software, networks with AI, and how this is unlocking new opportunities to tackle complex challenges in various sectors, such as agriculture, healthcare, manufacturing, safety, and security. Let's discover how the AI ecosystem of companies can empower you to address these issues effectively and drive innovation forward. Stay tuned as our ITU colleagues share a link in the chat for upcoming sessions, and we encourage you to continue being part of these insightful discussions. Before I introduce our speaker today, I would like to highlight a few logistical items. First of all, questions from the audience will be taken during the Q&A session after the fireside chat. If you have a question you would like to submit, please do so by typing in the Q&A window on the bottom of your screen. Please also indicate the city and country you are connecting from. Finally, the fireside chat is being recorded, and the recording will be made available on the event website. Thank you very much for your time and attendance. Now it is my pleasure to introduce our moderator who will be introducing the speaker of today. So the moderator of today's session is Rana Camille, who is the IoT Ecosystem Architecture Solutions Manager at BT. Rana, good afternoon and welcome to the session. The floor is yours.
Good afternoon, Thomas and everyone. Thank you so much for the lovely introduction. I hope you are all doing well. My name is Rana Camille and I will be your moderator for this fireside chat. In today's fireside chat, we will explore the intersection of advanced semiconductors, software and networks with artificial intelligence, highlighting how this synergy is creating innovative solutions for complex issues in fields such as agriculture, healthcare, manufacturing, safety, security, and beyond. You will gain insights into how AI ecosystems is evolving to meet these challenges, and you will also learn practical strategies to leverage these technologies effectively. To discuss these today with us, we have invited a distinguished speaker. Allow me to introduce him, Mr. Pete Bernard. Pete is an executive director of TinyML Foundation. He has been the executive director of the TinyML Foundation since April 2024. Pete, please.
Okay, great. Thank you, Rana, for the intro. Yes, good morning, good afternoon, and good evening to everyone. I am talking to you from Bellevue, Washington, where the sun is yet to come up. So it's nice and dark outside. Yeah, I want to talk today about this. Of course, we're going to talk about AI, but I wanted to talk a little bit about this other kind of AI, which is referred to sort of colloquially as edge AI, and sort of all the variants in between, including TinyML, and the real impact that it's having on industries and communities around the world. So let's kind of dig into it. Um, just a quick background on who I am. As Rana mentioned, I'm the executive director of the TinyML Foundation. Been there since April. I graduated from Boston University with a computer engineering degree. I worked in Silicon Valley for quite some time, did a number of small companies, embedded software there, embedded Java and BIOS, and then moved to Microsoft. I was there for about 18 years, did a bunch of products there, ran a bunch of groups, and left in 2023 and founded something called Excelsior. And then I joined TinyML back in the spring. So that's me. That's my background. Um, and so why don't we kind of get into it? First, always like to start by defining terms. Um, there's TinyML, there's efficient ML, there's edge AI, analog AI, neuromorphic AI, on-device AI. I think we're sort of bombarded on a daily basis with all of these different terms. And, certainly if you're trying to solve problems with AI, this is very confusing. Even if you're developing products for AI, it's kind of confusing. I consider all these under the same umbrella of really sort of where does AI meet the real world, right? So we'll talk a little bit more about cloud-based AI and all the attributes there. But the fact is that there's a lot of AI that's happening in the real world where the data is created, solving problems as the data is being created. All of that, as far as I'm concerned, sort of falls under a very similar umbrella. Maybe it's called edge AI or edge AI technologies or whatever, but it's AI that's running on sort of the edge of the computing network. So just to let you know, these are all terms that you probably have seen around, and I like to sort of bundle them all together in the beginning. So kind of stepping back a little bit, as we see in the news a lot, almost on a daily basis, AI has been sort of getting weird, as they say. Why is AI? How did it get so weird? But actually, AI has been around for a long time. I mean, the term artificial intelligence was actually coined in 1956 um, at a conference in Dartmouth in Massachusetts, and it's been happening for quite some time. The idea of mathematical models that can be trained and learned and detect. It's only until recently where semiconductors, networks and software have become fast enough where we've reached certain sort of milestones where AI has become more and more functional. And one of the things that sort of pushed it over the top, if you will, a couple of years ago when ChatGPT became more available, these types of models really started to, kind of, I would say, kind of get to our imagination and get to society's imagination and do all sorts of things. But the technology around artificial intelligence has actually been around quite some time. There's a ton of research and R&D behind it. And frankly, it just reflects society, right? So there's a lot of things happening in society that is being reflected through AI today around loneliness, around employment stress, all sorts of things that people are concerned about as technology becomes more pervasive in our life. And AI just reflects that. So I usually tell people AI has not gotten weird. Society has gotten weird, and AI is just reflecting that weirdness. Um, and that's just the way it is. So think of AI as really a set of technologies and tools and agents, frankly, that are reflecting the world around us. And that can be super positive, which we'll talk about. It could also be somewhat negative and weird as well, but that's okay. A lot of the cloud-based AI that you've seen these days is really been kind of, tapping into sort of our concerns about AI, but I'll tell you about why we don't need to be that concerned. One of the things that's really interesting in terms of AI is democratization. Um, and I heard the term yesterday about AI sovereignty, which is like, how do you run AI, without dependencies? How do you run it, on your own or within your own country or community without taking dependencies on externalities? So the democratization of AI is a really important factor. It actually plays into edge AI quite a bit. So the ability to use AI when you want, the models that you want, to be able to use your own data sets, to be able to train your own models, to be able to, monetize that and benefit from that as well. The governance of AI is really important. And these are complex questions, but really critical as you think about AI strategy moving forward. So how in control are you of the AI that you're taking a dependency on for your industry, for your farm, for your healthcare, for whatever you're doing? Super important. It is complex. I mean, one of the challenges around, full democratization of AI is that, as an example here, someone could take a fully open, kind of AI drug discovery tool and use it to create toxins as well. So, how do we provide openness around AI and interoperability and community, but also kind of protect the community from potentially, dangerous kind of AI models and things like that. So it's complicated, but it's something to think about how we move forward. How do you maintain control over the AI that you need to use for yourself, for your business, for your community? So super important. The other big question around AI, frankly, is it sustainable? We talk about sustainability all the time. I know within the TinyML Foundation community, it's a hot topic. You see a lot of things in the news around cloud-based AI being, pretty data intensive. Gigawatts of energy, acres of concrete, oceans of groundwater, and for what? So we have to be careful about how we are building out our AI infrastructure to make sure that we are doing it in the most not only cost-effective but also resource-effective way possible. You can see some of the stats up here. Some of the newer chips that are amazing. I mean, the NVIDIA Blackwell chip, for example, which is really state of the art, something around 1,200 watts of power for that chip. They're usually in bundles of 3. Compare that to some of the AI we'll be talking about a little later in the presentation, where we're talking about single watts or milliwatts of power that could be run on a solar cell or can be run on a battery that lasts 10 to 15 years. So, AI does not necessarily mean high power and high resource consumption. And that's really one of the big benefits of this whole movement toward edge AI and TinyML. Great. So edge AI to the rescue, I guess, is the punchline. How do we think about AI and how important it is and all the critical factors, but how do we do it in a way that provides democratization, provides sustainability, maybe dials down the weirdness a little bit. And that's really what edge AI is all about. It's a very hot topic. You can see this kind of Gartner graphic here, excuse me, where edge AI is moving toward the center. It seems like on a weekly basis, the growth in this area is fantastic. The whole growth around edge computing has been fantastic as well. If you think about all the cloud computing that's been happening with the hyperscalers, it has been fantastic. There's been many billions of dollars invested, but now we're seeing lots of capabilities being built on-prem, near-prem, in the farm field, in the hospital, at home, on the factory floor, and not necessarily requiring remote processing. And this is a long trend over many, many decades. Kind of the pendulum has swung back and forth. But today, with as I mentioned, the semiconductors, the networks, and the software, you really have to ask, why not run this locally as kind of your first statement. But it's transforming all these different industries. We'll talk about a few examples that are happening out there. And it's, running really, I would call it sort of cloud to edge or edge to cloud. Sometimes these are fully disconnected systems, but most often it's occasionally connected. There are really good reasons to use the cloud. So for example, if you're doing time series insights or analyzing data over time, or you want some more elastic compute, for some workloads that you might not be running locally. So there's lots of good reasons to use the cloud. But more and more, we're seeing industries being able to run these workloads locally. So it's becoming quite a hot topic. Okay. The other thing that's happening with Edge AI, as I mentioned before, is that it's really evolving quickly. I would say, I don't know about day to day, but it feels like week to week, someone is introducing a new model that's being, highly compressed and optimized, and things that could even think about running on the edge are now routinely being run on the edge, including large language models, or what sometimes people call small language models. It's a hot area. Being able to run things on MPUs and even down to MCUs, Cortex A down to Cortex M, is becoming much more commonplace. And really, there's so much R&D happening across academia in this space, to be able to do more with less. Right? It's always been, from an embedded software developer perspective, that is the envelope that you push. Is how much can I fit into this device, and how much work can I get out of it? In a lot of these deployments and a lot of these industries that I'll talk about, you're always looking for sort of the lowest cost solution, and the fastest to deploy. And so there's always a gravitational pull toward the edge, and a gravitational pull to fit more in here. Just an example, look at Meta and the evolution of the Llama models. It shrank about 10 times its size in about 9 months. The other thing that's happening, which is really interesting, is the evolution of not only fitting things into smaller spaces, but, as I mentioned before, the AI acceleration coming to semiconductors, whether it's introduced via ARM, or licensees, or new things being designed by NXP, or things from Qualcomm, or Intel, AMD. You're seeing amazing advances pretty much on a kind of a 6 months basis that is really far outstripping what's capable before, where you used to have maybe one top or 4 tops, which is a measure of sort of AI horsepower. Now you're talking about tens of tops, right? And then, soon enough, it'll be hundreds of tops. And even tens of tops is amazing, because if you go back a few years, that was something that you had only on sort of an NVIDIA gaming laptop. And that's pretty common today in many of the kind of fairly entry-level platforms. The other thing that's kind of interesting, and this is kind of a byproduct of that, maybe an enabler, is communication. So the ability to connect these devices and systems wirelessly is really important. And there's so many different ways these days to remotely connect edge solutions wirelessly. You have obviously a lot of the licensed spectrum technologies around, 5G, 5G RedCap, NB-IoT, et cetera, but also unlicensed spectrum capabilities with things like LoRaWAN and MIOTI and YSUN and all kinds of things like that. So there's no shortage of ways. One could argue too many different ways of connecting these things wirelessly, and people are doing it. So that's all. These things are sort of coming together at the same time to enable people to run AI workloads pretty much anywhere. And now we're talking about running, large language models, on Raspberry Pis and other kind of very small form factor devices. So you can imagine now all the different solutions that can happen. So why don't we shift gears a little bit, and we'll talk a little bit about that. Okay, I'm monitoring the questions. So let me talk a little bit about some of the verticals that are really being impacted by Edge AI. I mean, one of them is agriculture. It's pretty straightforward. The ability to, at a large scale, extract more yield by using AI across your crops and your fields, whether those are small, medium, or large, is really incredible. One of the projects that I saw that caught my eye, called iBees. But as you know, the bees and bee population is really critical to our ecosystem. And there's lots of things that can go wrong with bee populations, and that have been to now kind of blind to a lot of the kind of agriculture population. So, things around measuring hive weight, and hive being too dumpy and too hot, and all sorts of things over, including, security of the hive itself. there's some really interesting low-cost ways to be able to monitor this stuff and be able to make sure that it gets optimized. So this can really save, tons of bees in terms of their productivity. It can be deployed very inexpensively, does not require any cloud computing. And it's just an interesting example of, bringing AI and local AI and measurement into a pretty traditional process of beekeeping. Another really interesting example, and there's lots here, but there's a company that I'm familiar with called Caliper, and they're based in Australia. They do a lot of, I would call it machine learning kind of measurement in very, very robust and challenging environments. So, for example, they will measure in Australia, they'll measure the temperature of the train tracks. Because in Australia, if it gets very hot, traditionally what Australian rail systems have done is they've slowed the trains down as the temperature increases, the ambient temperature, for safety because of the expansion of the metal. What they do is they actually measure the metal and provide a more precise measurement. And so it's much better than measuring the ambient temperature. And then they don't have to slow the trains down as much. So they can be much more precise and more safe around the speed of the trains. This actually saves, as you can imagine, a ton of money because you're able to move goods faster. And just having more precise measurement and understanding of that analysis is helping them. They also do a lot in terms of water reclamation, detecting water leakage in water systems. They have gas detectors in sewer systems. So all this is using Edge AI to understand the environment on-prem. And then they're able to pull that obviously back into the cloud for analysis on a broader basis. So just a really interesting example. There's many companies in this space. I happen to know this one pretty well and really impressive. One of the challenges here, as you can imagine, you can sort of see these discs here, these tubes. Running AI and running compute in the real world requires pretty robust hardware, right? So if I'm running AI in a data center, I have racks and racks of compute that are air conditioned behind security and all sorts of things like that. But when I'm running it in the farm field or in the sewer, I have to build robust sensors with pretty impressive industrial capabilities, even as far as like rat-proof cables and things like that, so that these things can survive out in the real world for years. And so that's one of the interesting challenges. A lot of companies in the Edge AI space are also really good at building out industrial capabilities and containers and packaging. So you think about how to have that compute out there for long periods of time. In some cases, if you look at some of the batteries out there, they're designed to last, be solar powered and maybe even last for a decade or 10 to 15 years, so that the servicing costs are really low. So really interesting space. Another one, and actually, if you scan this little QR code, you can go to our YouTube channel. We just recently did a YouTube show. We have a show called Blueprints, and it talks about solutions like this, like Edge AI solutions. And we had the city of San Jose, which is a city here in California in the Bay Area, talking about pedestrian safety. And all the challenges of pedestrian safety. As you can imagine, whatever city you're in or country you're in, it's a challenge, especially at night. And so they had they have this program called Vision Zero, where they try to get pedestrian fatalities down to zero, and it's a nationwide, if not a worldwide effort. And they explained how they're using AI and AI vision to do pedestrian detection, to do counting of pedestrians, and doing preventative measures as they see pedestrians. You can measure the rate that a pedestrian is moving down a sidewalk. You can understand the state of the street light, and you can make accommodations. You can do all kinds of warning signs. So it's really an interesting space inside of smart cities around pedestrians and pedestrian management, where you really need real-time, analysis and AI. This is really using, as opposed to sort of the caliper stuff, which is using more sort of machine learning, this is using like AI vision models to do detection and counting and all sorts of other things like that. But if you go to the QR code, you can watch the show, and they have some interesting demos in there. But this is really becoming super critical for a lot of cities. And the cool thing about this stuff is that, like the cameras that they were talking about that are being used, not super expensive, and because they are wireless, solar powered, and wirelessly connected from a radio perspective, the deployment costs are actually quite low. So if you think about it, the last thing you want to do is dig up the sidewalk and run cables to install pedestrian cameras in the city. It really becomes cost prohibitive. In fact, my understanding is that the cost of a typical city of just going and opening a manhole cover can be like $50,000 US dollars. So very expensive to get crews out there to, especially to dig up sidewalks and things like that. So the ability to deploy edge AI solutions that are low cost, and can do the compute in a self-contained environment and can be solar powered, is really super valuable. And in fact, the deployment costs, I wouldn't say they're zero, but they're radically lower, which means you can put thousands and thousands of these cameras out there to help detect pedestrians and things like that. So anyway, really interesting example of where edge AI is happening. Okay, let's keep going. Let me talk a little bit about the community around it, because none of this stuff happens in a vacuum. It's very hard. Even when I worked at Microsoft, we could not walk into a customer and just solve someone's problem by ourselves. There was always lots of companies working together to do it. And that's really what the TinyML Foundation is about. We're about a community of developers, academia, technology providers working together to solve these kind of problems and move the industry forward. And we have a worldwide footprint. About 100,000 students have taken TinyML classes around the world. I mentioned the YouTube channel, which you should definitely check out. And a couple other things. I mean, in terms of the types of folks and groups inside the TinyML Foundation, we obviously have a lot of technology providers involved that are making tech, making software, making devices, making chips. But also we have a lot of solution providers that are putting things together. We have lots of commercial customers that are kind of on the buy side to figure out how do I use this tech. So we have a lot of companies and NGOs and policymakers coming to understand, what can I do with this stuff? I mentioned government policymakers as well to kind of get educated as to state of the art. And then finally, in academia. So many classes, and maybe you have a number of students here on the call as well, studying this Edge AI technology. One of the cool things about Edge AI is that it's very accessible to learn and to build things. So you can get kits, you can get Arduino kits, Raspberry Pi kits, kits from Qualcomm, kits from ST Micro, and build some amazing things that actually work right in front of you. So we have lots of academia using the Edge AI technologies as well. We also have a number of working groups. We try to move certain things forward in the industry. A lot of questions around data sets. I didn't get into AI architecture, but if you think about the foundations of any kind of AI solution, it starts with the data set. So what is the data that you're training the model on to get your results? If your data set isn't good, your model's not good, and then your solution's not good. So there's a lot of problems out there with kind of quality data sets, and so we're trying to help solve that. And actually, we'll be providing some data sets into the community. We have our Blueprints working group that I mentioned about solutions, the sustainability working group working with organizations like the ITU and the UNICC, and how we bring those resources to bear, and then marketing as well. So how do we better tell the story? Some of our academia partnerships I mentioned before. You can find all kinds of curriculum out there. If you'd like to get educated about TinyML and Edge AI, you can go on Coursera or edX. There's incredible classes out there, a lot for free. And that's pretty cool. And so you can get educated whether you're a professional or a student, and actually do some hands-on work yourself, which is fantastic. The other thing that we're doing, I mentioned before, working with the ITU, We're a member of the World Economic Forum and their AI governance team, bringing sort of edge AI capabilities kind of into that conversation. And then we also sponsor hackathons too. So we actually did a pedestrian safety hackathon with San Jose and some of our tech partners as well that we do. And a bunch of logos here, but one of the things when you think about the edge AI ecosystem and TinyML, it's a mix really of the major technology providers. You can see some famous logos up here, probably some logos you've never heard of as well, and some amazing startups and small companies, companies like Greenwaves, who's making a RISC-V based called a GAP9, which is used for hearables, kind of hearing aids. I'm using AI in the hearing aids. You've probably seen with Apple's recent announcement on the AirPod Pro what they're doing there. Inotera doing neuromorphic computing with spiking neural networks is pretty amazing, and others as well. So what's really cool about the edge AI world is that there's a real diversity to the companies involved. And if you want to contribute to that, whether it's your startup or working for someone else, there's lots of opportunities there. One of the other things you can get involved with is we do have events around the world. We have one online October 17th around Gen AI at the Edge that you can participate in, which is a freebie. And then we also have community events locally. So we have a big event coming up in Taipei, a day-long event on November 6th. And then we'll be in Austin, Texas in late February as well. So hopefully if you're in the area, you can join us for a day or two and meet people and see some hands-on demos and learn some things. This was an event we had in Milan in June recently, which was a fantastic event. And I think a 3-day event, which was pretty amazing. So just to kind of sum up, before we get into any question and answer, this is really about AI that's using less power, less cost, and having more impact. That's really what edge AI and TinyML and all the variants are all about. And really, there's kind of 3 big areas that has an impact. One of them is really, as I mentioned, accelerating business. So, using edge AI to have more control over your compute, solving problems where the data is being generated at a lower cost, at a faster deployment. If you're a student or you're trying to upskill as a professional, there's plenty of places to accelerate academia with edge AI. Lots of new things to learn, lots of hands-on things that can be built and to understand. And then finally, accelerating society. I don't think you can find a technology out there that's having more of an impact on local communities than edge AI. Whether it's through local water systems or agriculture or safety, it is just being deployed everywhere. And it's so exciting to see so many of the case studies. I only touched on a few here that are out there where edge AI is being deployed and developed at low cost without dependencies on the cloud, and is in control of the local community. So it's pretty exciting. So really, we see edge AI and all these variants as not only making digital transformation happen, but it's really a societal transformation as well. And it's really exciting to be part of it. I encourage all of you, if you're here, you're interested, and so I encourage you to take the next step to get more educated and more engaged to help us out. Fantastic. Okay, so that is the bulk of the
Excellent.
presentation. Thanks, Rona.
Thank you so, so much, Peter. It's been extremely interesting. Thank you for the very engaging presentation. And we have had a huge turnover. We have attendees from all over the world: India, Zimbabwe, Malawi, Jordan, Egypt, Korea, China. We have a very, very high turnover, and we're very pleased to have everyone. So it's been extremely interesting, and thank you very much once again. And now we move to the Q&A part of the session. We have some questions and answers that we will go through now.
Should I just start at the top, or how do you want to do that?
Well, whichever you prefer.
Okay, I see one up here that's pretty cool, and it actually. So the question is from Dilip. It says, so far we've heard that edge AI is being useful for measurement and monitoring. What about edge AI for interactivity with end users? So one of the really cool things that's happening is people are combining different AI modalities together to solve problems. So for example, they're using large language models with, more traditional machine learning and kind of pattern detection to solve issues. So imagine if you could open up the hood of your car that has thousands of sensors in it, and you could ask the engine, what's wrong with you? And the engine could use an LLM to actually articulate in your language, what all these sensors actually mean. So today, as you know, and I have an old car myself, you sort of have to figure things out, or you go to the ODB port and you get a bunch of codes. But more and more, we're going to see equipment become enabled with language. And we'll be able to take a lot of these obscure readings and sensors about itself and explain what's wrong with it or how it's doing to the maintenance person or the owner. And I think that's going to be it'll be a little weird, but we're seeing it happen, and I think it's really fascinating. So that's kind of an example of interactivity, AI interactivity at the edge that's happening out there.
Excellent example. And may I remind the attendees, everyone in the audience, is that you have a bar, a horizontal bar in Zoom, and there is a Q&A section in that bar. So we might not be able to go through the Q&As in the chat because I see a few questions in the chat, but the right way to extract them from the chat and get them to our speaker quickly is through the Q&A section. So Peter, would you like to answer the next question through the
Sure.
Q&A?
Here's one around benchmarks and data sets.
Very good
So I'll
question.
answer that one from Heiju Shin. And so there's a couple of answers to that. One is I mentioned we're about to actually release some data sets ourselves into the community. One of the ones that's really of super high quality is called the Wake Vision data set. If you go to our YouTube channel, there's actually an episode about that with some students from Denmark and Harvard that put this together. And so we're about to issue that, but you can get it at wakevision.ai. If you go there, you can get that data set, download it and use it. But there's more to come on data sets. In terms of benchmarks, we do work with ML Commons. I think ML Commons has done a really good job on a lot of their benchmarks. They tend to be larger AI focused, but they are doing more on edge and smaller. And we'll be partnering more with them moving forward. So I would keep an eye on ML Commons as well. So there you go.
Excellent answer. Shall we move on to the next question?
Let's see. The downsides of Edge AI and TinyML. Okay, that's a good one. What are the downsides? Well, I mean, there is a limit to the amount of compute horsepower that's available on the edge, right? Based from a cost perspective. One of the interesting things is like when people talk about running large language models on the edge, it typically is not an AI horsepower bound issue. It's more of a memory bound issue. So a lot of the large language models that are being run on the edge or being run in general use a ton of memory. And I'm sure someone's going to have a great breakthrough in this architecture at some point and figure out how to run these in smaller memory environments. But right now, even though you can get away with a kind of a lower tops horsepower on the edge, you may require a lot of memory, which could boost up the price of the device. So yeah, the downside is that there is obviously a limit to kind of the compute and memory capabilities that you have. Other downsides, whenever you're deploying, let's say we're talking about my pedestrian safety example, 1,000 cameras across a city, obviously you have to, deploy them, manage them, keep them updated, and all that stuff. And so there is a device management overhead as you deploy more and more devices on the edge. Now, there's tons of great solutions out there, whether it's from hyperscalers like AWS and Microsoft or from third parties to help you manage these devices. But that is a factor as these things become more and more capable. Like for example, firmware updates or what they call FODA, firmware over the air. So just something to think about. So those are two.
That's a very well-rounded answer from different angles and perspective. Very thorough. Thank you very much for that. And shall we move on to another question?
Let's see. There's a question here from Mark around, and I kind of went through this a little bit. How long would you estimate for the functionality enabled by the current so do LLMs to be available on edge devices. Um, so yeah, people are doing lots of POCs right now on LLMs on edge devices. In fact, you could argue AI PCs with Copilot is a kind of a shipping example of an LLM on an edge device. So generative AI on edge is happening right now. The example I had where you go up to equipment and talk to it and ask it how it's doing is POC right now. So, I would say certainly within the next year, you'll see deployed versions of that in the industrial space. I can't really speak to the consumer space too well. It could happen anytime. So it's possible. As I mentioned before, one of the challenges of running LLMs and edge devices is the memory footprint. So you'll probably see it first in more commercial environments where cost is not as much of a factor. So I don't expect you to be able to put an LLM in your thermostat anytime soon. That would be an expensive thermostat. But you know how the movie ends. It just gets cheaper and faster all the time. So getting there.
Definitely. Shall we move in? I can see a lot of questions. Our session is 15 to 20 minutes for the questions, so Peter's going to try to answer as many of them as possible. If we go beyond the allocated time, we may take some of them
I
offline.
know.
Also worth noting that the recording will become available for those who registered, to those who registered after the session. Okay, next question.
Let's see. Yeah, I think the questions are coming in fast that I'm answering them.
Very, yes, so many.
I need an LLM to actually help me answer these questions. That's the issue. Um, Sayed is asking, transforming real-time data processing in industries such as healthcare, autonomous vehicles, key challenges organizations should anticipate when deploying these systems at scale. So great question, because there's sort of the POC, the proof of concept, getting it working on your desk and showing your boss, and then there's actually shipping it. So my experience at Microsoft is there's a big gap between the two. And actually deploying stuff at scale requires, I mentioned before, that ability to remotely manage and update, provision, and also having the support and the long-term support of the platform necessary. So imagine if you were an oil and gas company and you're deploying 100,000 of these, edge AI vibration sensors out there. All that stuff needs to be really locked down before you roll your first truck and laying it out there. So I would say really thinking about the provisioning and support and maintenance long term of these devices is really important for scale. And that's all after you figure out the AI models and the data sets, right? So that's what I would really be thinking about. If you're a business that wants to use Edge AI, think about the deployment, support, and provisioning long term, in as much as you're thinking about tuning the AI models. The other thing is the AI models can drift over time, right? So as it gets new data, you could drift. And so how do you update the AI model over the air, and using reinforcement learning and new data to keep it calibrated and on target? So that's another one you need to think about. So
Food for thought. That's
yeah.
definitely very valid points. I particularly like the oil and gas example because I did work for an oil and gas company.
Oh,
I was in that area, and I can imagine what you're talking about exactly. That's a very, very good example.
yeah.
We have
Yeah.
lots and lots of questions coming
Lots.
in.
Here's one about learning, which is always important. So, from Rakesh, students and professionals, what's the starting point? Um, if you can provide links to start. There's a really great course, and I'll plug one of our board members, Professor VJ Reddy from Harvard. He created a course on edX on TinyML. It's very popular. I think it's free, but don't quote me on that. But that's a great place to start, and you can get an Arduino kit to sort of go with it and things like that. He also wrote a book, which is available on his GitHub repo called ml.sys, and it's all about machine learning. And so, you could definitely go out there and look for ML-sys. You can look for TinyML classes on Coursera or edX. And those are great places to get started with, kind of on your own pace, to learn about stuff.
Excellent. There's a question here from Kevin Holly asking if there is a risk of creating an edge AI botnet.
Hmm.
Does that?
Well, yeah, I
Yeah,
mean, anytime there's software, there's a risk,
of course.
inherently,
Yes,
right? And software is written by humans, or well, sometimes these days, but um, there's that's why you need to write security protocols, right? So things that are happening around security, we didn't really talk too much about it, but it's super critical. Encrypting the data in motion, encrypting the data at rest. We're seeing edge AI devices using what's called TPM chips to encrypt AI models to keep that secure. And so, using best practices for security is really important. The ability also to manage these edge devices and be able to, shut down devices and deprovision things is really important as well. So I think best practices security mitigates that risk.
absolutely.
Let's see. Here's one um, from Madhavan Palan, hashtag White House. I don't know if he's at the White House, he or she's at the White House. How's the community contributing to space tech? Um, yeah, so if you go to our YouTube channel, we had a talk with a gentleman from a company called Ubotica that's actually put AI vision capabilities into satellites. So traditionally, what satellites have done is they've taken pictures and then beamed the pictures somewhere, and that's kind of a slow process. So what if you could actually take an analysis of the pictures in the satellite itself? And so they're using AI vision to detect like methane leaks, early stages of algae blooms in oceans. So they can do pattern detection on images of the earth, and especially in the climate and environment, to do early detection of problems. So that was pretty cool. What's interesting about running chips in space, which is a whole other talk, is around radiation hardening. So anything you ship up there needs to have certain shielding and stuff in there to keep all the space dust from, corrupting your boards. So that adds, a little bit of complexity to things, but it's happening. It's happening. I was actually spoke at an avionics conference recently, and you're going to see edge AI used in space, not only in satellites but in other things, pretty regularly, I would say, moving forward. But they're solving those problems. They're solving problems with radiation hardening and other things. But yeah, if you go to our YouTube channel, the Ubotica video, you'll learn all about AI in space. Fascinating.
Excellent. I'm already excited about visiting the YouTube channel. I'm sure there will be a
A
lot to
lot on
learn.
there.
Yes,
Um,
definitely.
let's see, what else do we have? Oh, gosh. Are we able to integrate edge AI with smart meters? This is from Anonymous. In power grid networks, which have less reliable network and power in rural areas. Yeah, so the intersection of the power grid and AI is a fascinating space. Edge AI is being used today in a lot of areas for inspection of the power grid, inspection of towers and power lines. So using drones and edge AI vision, which is a great way to mitigate safety issues and to provide more access. But also, yeah, a lot of the newer transformers and things that are happening include sensors and capabilities to do kind of local analysis in real time of the current and the state of the transformers, so that there can be some preventive maintenance there. Um, so yeah, for sure. I mean, and smart meters, virtually all of us have smart meters these days, or will get them soon. Um, that's a more traditional kind of IoT deployment, but even those can do kind of local analysis on consumption and things like that. And using your phone and Bluetooth, you can query your local meter and get some interesting insights and things. So yeah, definitely happening. But I think for the big power grid stuff, I think the remote that using Edge AI vision for remote inspection and stuff is one of the really fascinating use cases. So.
Yes, definitely. It's going to be
Yes.
interesting. We have time for 2 or 3 questions at the most now.
Right. Here's one. Well, I'll just read the first sentence. This is from Todd. Do you equate Edge AI to IoT? Um, yeah, not exactly. So for me, IoT is, a low power, low cost piece of compute that's sending signals to the cloud, basically.
Mhm.
I mean, that's how we traditionally have thought about things. It's before IoT, we used to call it embedded computing, where you had this low power, low cost thing just kind of doing disconnected, doing its own thing. Then IoT said, well, let's send data to the cloud. Now I think Edge AI is saying, let's run AI workloads on that device, right? And then take action locally. So I would say it's sort of like the next gen of capabilities from traditional IoT to adding AI capabilities. Sometimes they call it AIoT. I don't know if that's a thing, but so yeah, I don't know. I don't equate them. They are cousins for sure, just like embedded computing is a cousin to IoT.
Yes.
There you go. You know, that's funny. I was going to say one of the things that the tech industry does is we make up words. You know, we just make stuff up. So, like my first slide about edge ML and efficient ML and analog AI, people are just making stuff up. So, you know, you have to sort of define your terms and to understand exactly what's going on. So, I always thought that was a fascinating. And being in the tech industry for decades, I probably made up a bunch of words myself too. So it happens.
That's
Um, let's see which app do we or what software do we use to create or make AI? You know, so that's a long answer, but essentially, there's a ton of tools out there to create the data sets, right? To create or download models from model zoos, right? And then tools to then train the model on the data set and then deploy the trained model into something that can then execute. And these are all, there's lots of open source tools out there as well as kind of paid commercial tools. So it's not a single app. And that's one of the cool things about this ecosystem. It's very democratized. There's lots of mixing and matching. Sometimes that can kind of cause some challenges. But yeah, it's all out there. It's all out there. And if you want to get into it, you can get into it on your own terms through a lot of open source software, which is pretty cool.
excellent. We have time for one question or two short questions.
Goodness gracious. Um, the future of studies and collaborative work. Um, I guess I'll do that. You know, I think that collaboration is the future. I mean, we have to collaborate. I mentioned before, like this whole thing is a team sport, right? You cannot solve these problems by yourself, or one company cannot come in and claim to have all the answers. So, you know, investing in the ability to collaborate is really critical. It's a critical life skill, frankly, to be able to work together and kind of pull from the best of your colleagues and your teammates and your technology partners. That's why I'm so excited about TinyML Foundation, because we're a community building organization, right? And we do things together. Certainly AI is helping in collaboration. You know, you're seeing sort of, you know, all the kind of traditional note-taking apps and summarization apps. You know, soon I'll be able to deploy my calendar agent to talk to Rana's calendar agent, and we'll find a convenient time to meet. And so I think AI can help, you know, people sort of find ways to collaborate and maybe pull insights together. But at the end of the day, this is still a human to human process where people need to work together and collaborate to get things done. And I think that's kind of the magic is when people can do that. So I'm a big fan of collaborating. Um,
Absolutely. It's
yeah,
definitely key for achieving anything impactful. Okay,
exactly.
we have time for one more question,
I
one
don't know. Do you
last.
see one here that stands out to you? I mean, it's like kind of an overwhelming number of questions.
Oh, yes,
Um,
and they're increasing as well. So,
hmm, let's
one
see.
one from Said, we might have gone through this. It says, how will Edge AI
Hmm.
operate in real time if data is in the cloud? And
Yes.
yeah, is it just the usual edge computing? That's the second part of the
Yeah,
question.
so there's this interesting interplay between cloud and edge. And actually, you can think of these solutions as multiple points between the cloud and the edge, right? So you may have a hyperscaler cloud, you have an Azure data center way out there somewhere in Dublin or
Yes.
somewhere in Ireland, right? And then you've got maybe some heavy edge equipment, you know, many kilometers away. And then you've got some maybe on-prem equipment that's also running, you know, AI workloads. And then you have sensors running workloads. You may have like four levels of compute in your solution. all running AI workloads. And there's this term called orchestration or software orchestration, which really kind of can help determine what software runs where and why, right? So it's becoming very sophisticated. It actually, if you look at study things like Kubernetes in the cloud, the idea of software orchestration is really important because you're deploying different virtual machines on different clusters to do different things. Imagine taking that and saying, okay, now I'm going to deploy, virtual workloads outside the data center onto edge devices. So if you look up like Azure Kubernetes Service from Microsoft, and there's other companies doing this, they're actually bringing that type of orchestration capability to edge devices and even sensors themselves, so that everything looks like a resource from a cloud perspective, including the sensors and the gateways and the heavy edge equipment. And that's really the future, is that this kind of I call it a multi-cloud, multi-edge world, where you're going to have virtualized software workloads running across all these different things, and you'll need to sort of orchestrate what runs where. So yeah, pretty exciting.
Excellent, very exciting indeed. And that comes to the end of our Q&A session. So thank you very, very much, our distinguished speaker, Pete, for his valuable contributions to our audience. And thanks very much to the audience for engaging, for the questions, and for joining from all over the world. Your participation makes these sessions as dynamic and impactful as they already are. They make it more dynamic. It's a pleasure having you all. Now I would like to give the floor back to Thomas. And thank you so much, Pete, once again, and hope to host you in future sessions.
One more pitch, if you want to go to our Discord channel.
Yes,
there's
definitely.
a QR code here. Join in the conversation. It's a worldwide conversation on this topic, so go to Discord.
Excellent. Let's keep the conversation going.
Exactly.
I've personally enjoyed it so much and would like to take part in further conversations with you in the future. Thank you very much once again, Pete. Now we pass the floor on to Thomas.
Okay.
Thank you. Thomas, are you with us still?
Sorry for that. Thank you, Rana, for hosting the session. And thank you once again to everyone for joining our session, and Rana for the wonderful moderation, to Pete for the insightful conversation, and of course, the audience for attending and participating in this session. So I encourage everyone to join our events. We have the webinar City on Horizons, celebrating World Cities Day and shaping urban futures, on 31 October from 2 p.m. We also have the expert session, Ask the Expert session on smart submarine cables, Future of Disaster Management on 5 November 2024 at 2 p.m. We also have a fireside chat on quantum leaps, pioneering the future of quantum computing on 28 November 2024 at 2 p.m. So keep an eye on IT website to see information on our upcoming discussions. These are wonderful opportunities to delve into the new and exciting developments in the digital transformation space. And of course, we encourage you to attend. So thank you once again for your participation and contribution to this fireside chat. And we are now officially concluded. Thank you, everyone. Have a wonderful day. Bye-bye.